Dangerfield Industrial Systems Company, DISC, is trying to decide between two different conveyor belt systems. System A costs $430,000, has a 4-year life, and requires $110,000 in pre-tax annual operating costs. System B costs $570,000, has a 6-year life, and requires $98,000 in pre-tax annual operating costs. Both systems are to be depreciated straight line to zero over their lives, have zero salvage value, and must be replaced when they wear out. If the tax rate is 34% and the discount rate is 11%, which project should the firm choose? Because the projects have unequal lives and must be replaced when they wear out, we need to consider the equivalent annual annuity cost for each system. For System A, let's go ahead and calculate it. We're told the annual operating cost is $110,000 per year. We need to deduct from this our depreciation expense of $107,500 per year, which is the $430,000 project cost divided by its 4-year life. This results in a decrease in taxable income of $217,500 per year. Since our taxable income decreases, we'll pay less in income taxes. Thus, we have tax savings of $73,950. This is our change in taxable income multiplied by the 34% tax rate. Our change in net income then is $143,550. We add back our depreciation expense of $107,500 and find the annual operating cash flows for System A is negative $36,050. The next step is to calculate the present value of this 4-year negative operating cash flows. We can do this with our financial calculator. Enter 4 for the number of periods. We had a 4-year project life. 11%, the discount rate, is entered for the interest rate, and the $36,050 annual operating cash flow is entered as the payment. When we solve for the present value, we find it has a negative present value of $111,843. We also need to consider the project cost, which was $430,000. Thus, on a net present value basis, System A has a negative $541,843 total cost. System A, however, lasts for 4 years, so to calculate the equivalent annual cost in our financial calculator, again, we'll enter 4 for the number of periods, 11% for the interest rate, and this time we'll enter that negative $541,843 cost as the present value and solve for the payment. We find Project A, or System A, has an equivalent annual annuity cost of $174,650. For System B, we began with a $98,000 a year operating cost. We deduct from this our $95,000 in depreciation expense, which was our project cost over a 6-year life, to get a change in taxable income of $193,000. This will result in tax savings of $65,620, which again is our change in taxable income multiplied by our 34% tax rate, resulting in a decrease in annual net income of $127,380. We add back our $95,000 in depreciation expense and find System B generates an annual operating cash outflow of $32,380 per year for 6 years. We need to calculate the present value of these cash flows. So in your financial calculator, enter 6 for the number of periods. It has a 6-year project life. Enter the 11% discount rate for I. Enter $32,380. That was our operating cash flow for the payment, and solve for the present value. And we get a negative $100,457 net or present value for our project's operating cash flows. We need to add to this our project cost, which was $570,000, and on a net present value basis, we find System B cost $670,457. This cost needs to be spread out over System B's 6-year life, so we need to calculate the equivalent annual annuity cost. In your financial calculator, enter 6 for N, 11% for the interest rate, and enter the $670,457 as the present value, and solve for the payment. We find an equivalent annual cost for Project B, or System B, of $158,480. Since Project or System B has the lower equivalent annual cost, we should select System B.